Hi, welcome everybody, with a short delay because of connection issues. My name is Simon, and I'd like to talk to you about CQRS in the small, and there's a subtitle with Modern Java and jOOQ. So we will see how we can maybe improve some API stuff using a different paradigm. Few words about me. I'm from Switzerland, and I'm active in the Java user group, also in Switzerland. I'm working as a self-employed consultant in Switzerland and working for many customers. And recently, I discovered a pattern when I look at communication between front-end and back-end. So my talk will be about this kind of applications where we usually have a client built with React or Angular or Vue. And then we have the server. I usually use Spring Boot to do that. Also, my examples will be with Spring Boot. But the question here is, how do we communicate? Because the paradigm here shifted. You know, I'm already working in software industry for around 30 years. And back then, and that's also why there's title client-server, we had client-server communication. And usually this was kind of a remote procedure call style, later remote method invocation, so we had semantics. So we did a call like calculate price, add item, create order, stuff like that. So we had verbs. And like 10 years ago, this shifted to REST APIs. And there we only have the verbs from HTTP. So we have get, post, put, delete. And we don't have procedures or method that we call. We create, update, or read resources. And I realized that this gives kind of a problem in semantics, because if you really want to know what happens, you have to have a look at the server side. And I will show you an example in a few minutes where we have a traditional build application. And I call like the pattern that I recognized the mapping waterfall. Maybe you know about that. You have a REST controller, for example, Spring Boot. You get JSON content. Then the JSON content is mapped to a DTO. The DTO is mapped to an entity. The entity is passed to a service and a repository, and there is usually Hibernate that maps the entity changes to SQL statements and executes it in the database. That's when we want to write the data, and when we read the data, it's more or less the same, just we call the repository, and then we map the entities to DTOs. Who of you is doing that usually when doing APIs? Okay. In my opinion, this has a bit of a problem, so let's have a look at some code. By the way, I just forgot, I wanted to add some AI in my talk, but my talk is not about AI, so I thought maybe I could create a picture with AI, and that's the waterfall from DALL-E. I think it turned out very well, but it's not about AI, it's just some applied AI. So let's go have a look at the code. That's my model. So I have a customer, a purchase order. A customer can have many orders. We have an order with many order items, and an order item has a product. So very simple use case, nothing fancy here. But let's concentrate on the controller. And this is a Spring Boot application. So we have a REST controller here that uses a customer repository, a purchase order repository. We have no service here because there is absolutely no business logic in here. And we have a model mapper. So usually people use model mapper or mapstruct to map stuff. And as I said, I'm already working a very long time in the industry, and we did that already like 25 years ago. So when the layered architecture became popular, we were mapping between all the layers. So we had different objects on each layer, and there we were using like bean utils, I think was the name of the Apache project. That is more or less the same as model mapper. So mapstruct is more sophisticated because it generates code. Model mapper is good enough for my example. But when we look at the code, we see like we have a post mapping, a put mapping, and a get mapping. And it's quite boring because with the post we get the whole purchase order DTO. This one is a simple class here with a list of order items, and the order item has a product DTO, so it's more or less exactly a one-to-one copy from the entity model. So that's maybe already the first thing. Why do we have an exact copy? Couldn't we use entities on the API? Depends, right. Let's have a look further down. We also have a pot mapping, so we can update that. But what we are doing here, we are updating the whole purchase order. Is this a good idea? I don't know, because I have no idea what this really updates. I'm sending the test, I can change it, I can change the IDs, and what happens then? So probably not so good idea. And finally, we have like get mapping to get purchase orders. We can search by first name, last name of the customer. We also have paging built in because we probably have many orders, so it doesn't make sense just to fetch everything. And here we see the mapping code, right? So we read that from the database, and then we map that. So these are two concepts. We have reading and writing. And the interesting thing about what happens here, and this is a common issue, so I just start, let me start the application. Where do we have it? I have to start that one. Right. So this application starts a test container with the database and populates the data with flyway scripts, so nothing fancy here. Maybe why did I start an application in the test source or source test directory and not in the source main directory? That's because Spring Boot added support for test containers in 3.1, and with that I have access to the test class path of my application and can use test containers to run my application locally. So that I don't talk about that, but as you can see the code right here. So it started, and now I have some requests. So let's start with that one. So I do search for first name and last name, but not with some data in it, just with the person sign to get all the data, and I also turn off more or less paging. I fetch all the data that I have. And if I run this request, it will take a while. Because there is a lot of data in the database, but the interesting part here is if we look at the console of our application, we see that one. So I turned on Hibernate logging, and I can talk and scroll and talk and scroll, probably for the next half an hour. This is the n+1 select problem. You may know that. The problem is that when we have a look at the model here, we see two one-to-many relationships, and they're loaded lazy, and the mapper issues a fetch. And with that fetch, we will get some additional SQL statements for every part of, or every level of the mapping. We could improve that, right? We could do join fetch or entity graph, but we have a problem, and I did that on purpose because in our entity model we have lists. So the customer has a list of purchase orders because we want to sort them by order date, and the purchase order has a list of order items because we want to sort them by ID, and that's something that Hibernate isn't able to do because it must sort by two different relationships, right? And it builds a Cartesian product, and that's not possible to sort that way. So we have to kind of solve that problem. But getting back to the initial problem, what we get with that kind of approach is we have something called overfetching. So because we just have the purchase order DTO as the main entity that we want to send over the API, we usually fetch too much data. So the client more or less gets everything, and then he picks the stuff that he needs. So this results in the n+1 select problem, for example. And also the same is the other way around, if we send the purchase order to update the purchase order, we send too much data. And it's even worse because we may introduce some bugs because we could change everything in the purchase order, and if the server does not check if only the data that is allowed to change has changed, then we have maybe invalid data at the end, right? So we just move it back and forth. On the other hand, there is another issue. Sometimes we do too little. So we have something called underfetching, and this will require multiple calls from the client to the server, and this will just move the n+1 select problem that I've shown you before with the SQL statements to the client side. You will not see that on the server, but you could see that on the client, because if you have a page and display data, there may be like 20 or 30 requests just to display the data on that page. And on the other hand, we have maybe the problem that we don't send all the data that we need to update or to insert, and then we have multiple requests to update or insert data. That will mean we lose transactionality, so we don't have ACID transactions on the client, and this may result in inconsistent data on the server side. So that's the problem when we do kind of a naive way to build a REST API. And I was thinking about that in a recent project, how we could do that better, and I ended up with quite an old pattern. It's called CQRS. That stands for Common Query Responsibility Segregation, and was initially described by Greg Young 14 years ago in 2010. And there's another pattern called Common Query Separation. It's by Bertram Meyer, the guy who created Eiffel, or was working with Eiffel language. And what he said, Bertrand, he said, you can't have a method that reads and saves data at the same time. So that was his idea. And Greg Young took this idea and created kind of a architecture pattern to do the same on the architecture level. So this is the simplest form of CQRS, where we have a client and we separate just commands and queries. So we don't send kind of DTOs as commands. We send DTOs, but not the purchase order. We send a command that says something what we want to do. So there's also the command pattern of the gang of 4 that also do or describes a similar approach. If people who knows already CQRS or heard about CQRS, and if you hear CQRS, you always hear about event-driven, right? Now, on my picture, there's nothing event-driven, right? Because CQRS has some levels of adoption, how you want to do that. So the first thing that Greg Young is talking about is that one, just separate command and query. The second approach that he says is don't build UIs as you did like CRUD UIs. Build it like task-driven UIs where the user does not fill a huge form but has more like a wizard approach in entering the data. That's easier for users that are not used to use the application. And finally, because we have a command, we could easily validate the command and transform it to an event and then store this event because this is separated, right? But in my example, I don't do that. I just have a single database, but I do the separation with that. And how could that look like? Here we have an example. So in the upper part of the slide, you see a command. It's called add item. We will see what it does in a minute. And what we need there is something like a command handler, whatever that is. We will see that, how we can do that with modern Java, for example. And on the other side, we do a query that find orders, and this needs some query handler, and we will do the lower part with jOOQ, because that has a powerful feature that is not available with Hibernate or any other technology currently. So let's have a look at modern Java, how we can do that. Finally, in Java 16, there was a concept introduced in Java. It's called Java records. The idea of Java records are you have a single constructor, you have then getters, but without the get prefix, and this data structure is immutable. So it's perfectly fine because we don't want to change queries or commands, it's immutable data. And here we see the add item command, and as you can see here, we don't send the order item. We just send the IDs, and here the payload is quantity, just to add the order item. So there is nothing that is too much in that case, right? And then I was thinking about how can I structure my records, and I ended up with another Java feature, it's called sealed classes. I had a very hard time to find a use case for sealed classes in the past. I have one because I'm doing UI development with Vadin, so I do Java development in web UIs, and there you have a lot of hierarchy, and then maybe sealed classes work very well. Here's an example of that. So we have, for example, an abstract class shape, and then we define that sealed, so it's not possible to change that, but we only permit circle, rectangle, and square. So it's clear in that case that the shape can only be one of these three. Right? And we will see how I use that in the command handler. And there are other features that I also used, like we have the switch expression now, since Java 14, where we can yield some result from the case statements. That's something that I used as well. And with that, in Java 21 finally, or 2017, sorry, we had pattern matching. Pattern matching means that we can have a switch on the type here, in that case of the shape, and we have circle and rectangle for that. And this even gets better with Java records. And now we have something called record patterns. And with that, we can kind of destruct the record that we get. So we have the record pair, and instead of making the pair having a variable pair, for example, we destruct it, and then we can directly access left and right. So that's a very handy idea. So let's have a look at how this could be implemented in my case. So there is a second project. You will get the link to the source code as well. And here's the CQRS project, and that one has separated packages for the commands and for the queries. And here we have an interface order command. I use that to structure a bit my commands. And this, in that case, is a sealed interface. And I use that just as a namespace, right? So it's just, you don't have to do that, but to highlight the new Java features, this works very well. And then I have my commands. So I create an order, I add order items, and I can update the quantity. And I just have the data that I need. And what I did additionally, I added some bean validation annotations just to validate the input of the command. And then this is passed to a command handler. And this class has just a single method. It's handle. And here we get the command. And here we see the switch statement with the record patterns. So the switch expression here is also exhaustive. That means I have to write cases for all my commands. That's also something that's very helpful. So if I add another command, I get the compile time failure, and it says I didn't cover all the possible values of order command, for example. And here, that's just for demo purposes. Whatever happens with the command is something completely different, right? So I have just a single order service that can create the command, create an order, or add an item, or update the quantity, and that's it. Now the question is, there is no API at the moment, right? And the good thing about using this type of commands to write data is I can have many APIs if I like to. So in that case, I just created an order command controller. This follows a bit like a RESTful approach. So we have a post mapping, a patch mapping, and what else do we get? Now we have two post mappings, one to create orders, one to create items, and one to update the quantity. But at the end, it doesn't matter, because it's absolutely irrelevant how we execute the command. We could also have like a single post, like we had with SOAP, for example, or if you use GraphQL, you also have just post with the payload that happens, and here we just send the commands there. But what we could do, we could also send the commands via messaging, for example. So it really doesn't matter which API we choose. So we have like a separation of concerns in the transport of the commands and in the execution of the commands. So that's the idea here. Now, on the other hand, we have the query side. And for the query side, we want to have something like a nested structure. So we have the customer here, that's also a record. And we have a purchase order. Sorry. Like that. And the purchase order has a nested structure, order items, and the order item has the product. So it's a nested tree, right? Why I'm talking about that, the problem is you can't do that with Hibernate. You can't fetch this hierarchy in one go. So you have to have multiple statements for that, or you get a Cartesian product that has to be separated inside the nested structure. But there's a tool that can do that, and the tool that I like to show you is called jOOQ. jOOQ stands for Java Object-Oriented Querying, and is the idea to bring back SQL in a type-safe way into Java. So that means we have such a structure here. For example, we have the database, and jOOQ has two parts. First of all, we have a domain-specific language, and this is more or less SQL in Java. So you can write SQL statements in Java. What's the benefit of having a DSL instead of putting that in strings? The point is you have compile time safety. So with the DSL, the compiler checks if your SQL is semantically correct. If you have a string, this happens at runtime, more or less. And that's one point. And the other point is we want to have that type safe in terms of if the database changes, we want to get also compile time failures if, for example, someone changes the database table name or a column name or remove the column. And for that, we have the jOOQ generator that is generating a meta model based on the database. Maybe you already seen something similar. There's Query DSL, does similar things. Or if you're using JPA Hibernate, you have the meta model API that is generating such metadata based on your entity mapping, right? So that's a similar approach, but here we are purely on the SQL level. Now, why do I think that jOOQ is a good fit for that? We will see how this works, but as we don't have any mapping in terms of what you do with Hibernate, with mapping all the relationships, we are on a plain SQL level, so that means we do insert, update, and deletes, for example. And this probably works very well with commands because we want to have just a little update of the data, and we don't want to read data just to update it, right? So if we don't have kind of huge business logic, we just want to update some data, it doesn't make much sense to select data from the database and then change it and let Hibernate write it back to the database if I can do that in one go. So that's my idea about that. I can create minimal updates. But that's not the most important thing because that's not like much better than we use with Hibernate. But on the other hand, we have the queries. And because there we have nested structures, jOOQ has a superpower. It's called multiset. So that means I can write the SQL statements that fetches the data in a tree structure. By the way, SQL expert group is also talking about nested structures, because currently the only way to get, or if you execute a select statement, you always get back a table, right? So you don't get nested data. You could emulate that, and that's what jOOQ is doing behind the scenes. Since mid of 90s, you can fetch XML data from the database. And since, I don't know, maybe for 10 to 15 years, you can do the same with JSON. So that means you can really read trees from the database, but you have to do a trick. You have to use JSON, for example. So not with plain SQL, but with JSON functionality. And because this works very well, I'd like to show you how jOOQ works. So first of all, we don't have any entities. What we have, if you use jOOQ, we have the DDL statements or the database. And here in my case, these are Flyway scripts where I create the table. And I use some sequences for the primary keys. And that's it. So this is plain SQL. And then I have to have a way how I can generate this meta model. And for that, there is a Maven plugin, or also for Gradle, there's a plugin to do that. Now, in the last 5 to 10 years, technology was very important, in my opinion, and changed the way how we develop software. That's containers or Docker, right? So a lot of people are using that. And there is a framework called test containers that is used a lot. And the test containers saw that there is a need for spinning up a test container for the database, and then to use some generator like jOOQ to generate a meta model based on this database that was created. And therefore, one of the developers at Test Containers created the Test Containers jOOQ CodeGen Maven plugin. And this is an opinionated plugin. That means we have test containers. Here I use Postgres. And this one will spin up a Postgres container. So I can define the type here. If I don't define any image name, then it will just use the latest Postgres image. Then I can choose between Flyway or Wikibase to apply the SQL statements. And finally, I have the fully fledged jOOQ generator annotation here that I can use to generate the data. So I don't dive into that, so jOOQ is just as an example. But if I run that, then jOOQ will generate classes. And I'll find that here in generated sources. And what jOOQ does, it generates a class for each table. So the same as the meta model from JPA is doing for an entity, does jOOQ for that. And this means if you have a look at the customer, we see that we have like here constants like a customer that represents the table. And we also have like constants for each column. And I can use that meta model to construct the SQL. And if I change the database, for example, I change the first name to name, then my code will no longer compile. And that's the idea of jOOQ. So let's have a look at first at the command. I have here a service that is using jOOQ. We have this DSL context, that's the domain-specific language. And if you look here at maybe this select statement, we see that looks like SQL, right? So it's SQL as Java code. And here we see that we use this generated constants to get this type safety. jOOQ not only generates table, jOOQ also generates something called records. And a record, here we see one for the purchase order, is kind of an implementation of the active record pattern. That means I can create a new record here, and then I set the order date and the customer ID, and then I can call store, and store is like save in the Spring Data JPA repository. It does either an insert or an update statement, depending if it's a new or an existing object. But compared to JPA entities, it's much different because this represents a single table. So there are no relationships. That also means that I here set the foreign key and not a customer as a reference, right? And then I use it to update the data, so I can, or let's see here, I can directly issue update statements, for example, also with this DSL. But that's not the superpower. The superpower we will find if we have a look at the query, because here I have a query with a get mapping. I have a class find orders, that's also record, that's my query. That holds the first name, the last name, and then here I have offset and limit also to do paging. Maybe offset and limit is not the best way to do paging, but it's an easy way to show it in a demo. And now let's start this service here and see what happens if I execute this method. So I have more or less the same request. As we can see here, it just executes this method. But this time, it's much faster. It's not as fast as it could be, because it's still a bit slow. It takes 1.5 seconds. But if you have a look at the console of the application, we see just a single SQL statement. That's this one, right? So I have this SQL statement also as a Scratch file, I think. Let's analyze that. Here, that's the complicated query that is generated. And what you see here, it really uses JSON functionality from the database. So jOOQ fakes something that is missing in the SQL standard, this nested fetching, and uses JSON arrays and objects to generate the result. And we also see here the sample, so jOOQ, this always logs the statement twice. Why does it log it twice? Because jOOQ always uses prepared statements. So jOOQ is safe from SQL injection, but this has a problem because prepared statements, you just see the question marks. You don't know what the parameters are, and because this is usually something that you want to know, jOOQ also inlines the bind values just for logging that you see the statement. And if you look back here, we see that we have here the question marks, and here we see what's really inside the parameters. And if you have a look at the result, we see that we have the first two columns are as usual, and then we have a nested structure to get the customer in the purchase order. That's already JSON, and then we have the multiset that is a list of order or an array of order items directly in this query. Now the good thing about that is you just get one SQL statement, right? So it's faster just because it's one statement instead of a few thousands that we had with the n+1 select problem. But the question is it faster? So if I apply a fetch join to my relationships and change the list to sets that Hibernate can handle it, then it may not be that big difference, right? Maybe Hibernate is even faster. Why? Because the JSON functionality is maybe not optimal for the execution plan to get the data from the database. So it's a trade-off. So you have to check if this nested structure is faster than if you get a Cartesian product and just split the result set apart. It depends. I also don't have any indexes. For example, I should add some indices on like the first name and last name, then this will be already a bit faster. But now we need to know how we can construct such queries. And this query for someone who sees jOOQ for the first time may look a bit scary, but the difference here to Hibernate is I'm exactly telling jOOQ what to do. So it's declarative, and I know what happens because I tell jOOQ how to do it. So I can select the order ID and the order date. And then the row that's called value constructor, I create a column, a virtual column, that holds the first name, last name, street, postal code, and city of my customer. And here we see something that you may know from Hibernate. It's like navigation. So jOOQ can navigate over to one relationships. Like if you write JPQL code with Hibernate, you can also navigate with the dot operator over to one relationships. And then I can already define a mapping. So that means the result here from that row will be a customer, so my customer record. And then I have, for the order items, I have the multi-set where I have a nested select statement with the order item information, and again, the product that is also mapped to a product, and finally this is mapped to an order item, and the result is then mapped to a purchase order. Right. So that's everything that I have to do to get a nested structure, and this reduces the amount of SQL statements that are executed. And in my opinion, I would always use jOOQ for reading because it's much more convenient. You don't need entities. I even wouldn't ever recommend to use entities just for reading because entities are made for changing. That's why they have this persistence context and the state model behind. There is a Hibernate stateless session where the entities are not writable if you read them. But usually I prefer to write SQL directly because I know the data structure, and with that it's easier to understand what exactly happens, and I never need a mapper on the read side. Right? On the write side, I also could use Hibernate. It doesn't really matter. There, the point is I get commands and I add semantics to my API. So I no longer have a post with something, but I'm back to remote procedure calls where I see what I want to execute and not just changing a resource with a post, for example. That's the idea of my thing. So the example project you find on my GitHub. It's CQRS meets modern Java. There you can try it out yourself. And to conclude, in my opinion, the idea of applying CQRS such in a small context on just the API level helps to improve the understandability of the code. Because if you look also at the client, you there see a create order command. You don't see a post to an API that's /API/orders, for example. So you see the semantic what it should do. And if you're focusing on the separation, you will not over or under fetch because you will make an API that fits the client. So that's often also kind of a problem. I didn't go into that, but what I often see is that the front-end team and the back-end team are separated with like a wall between them, and also a wall in terms of time. So sometimes the back-end team starts to write an API before they even know what the UI is doing. So they just have their entity model and then they build an API based on the entity model, and the UI team must use the API to use it, right? But in my opinion, that's not a good idea. I would try to get them back together and work together on a feature. So in that way, the API will be easy to understand and better to maintain, and you really avoid this under and overfetching. So you don't have a general purpose API for that. And if you're using that, especially the jOOQ way of loading nested structure, you don't need the mapping anymore, so you can remove model mapper or mapstruct. And I didn't go into that, but it enables an event-driven approach. So you can take the command, validate the command, and then create the data and issue an event, and this event can consume, and then you can do the fully fledged CQRS with separate stores for the events and for the querying. And this is much easier to do because the commands already are kind of the event. They are not the event, right? They are just a command to tell the server what to do, but it's very close to the event that will be generated then from that. And if you do that with a patch or a pod statement or something like that, then you have to figure out what really changed on your entity model and then have some magic that will maybe create the event based on the changes. Yeah, that's it from my side. Do you have any questions? Yeah, the question was about how many data that I have in the database. I think I have 10,000 orders with some thousands of order items. And the second part was if I compared it with fetch join from Hibernate together with the nested thing. And they are more or less the same. So the execution plan, at least with Postgres for the JSON-B functionality, is not that bad. I don't know exactly, but Oracle was working very hard on JSON functionality in version 23 that came out last year. And probably this is faster because Oracle is usually a bit faster than Postgres in selecting data. But it really depends also on the indexes you will add. You really have to compare the execution plan, which one is better. It depends a bit. That's why I also had paging. So if you page it, probably it doesn't really matter, depending on what you fetch, right? But I would say that the JSON-B functionality in Postgres comes with the price. It's not for free, and it's not as fast as reading tabular data from the database. Yeah. The point is, you can. jOOQ.org is a great website, by the way. It's run by Lucas Seder. It's a friend of mine from Switzerland, and he has a blog. And he talks a lot about SQL. He writes about a lot of optimization of SQL. And the problem with offset and limit is that if you do a fetch now, and then in a minute, you may lose data, or you may fetch data 2 times, because it's possible to delete or update or insert data in the page that you are currently viewing. And therefore, there's something called key set pagination, where you don't fetch the data by offset and limit. You order the data. That's very important. I mean, ordering is important for making that work also with offset and limit. But then you fetch from a certain point, so from a certain ID, for example, or maybe you can use the row ID of the database table. Yeah, you can find that if you Google for key set pagination, you see how this could be improved. Yeah, the question is, how do I use unit testing? In that example, I don't test on that layer. So the tests that I have are on the API layer, and here I do a mock MVC test. But if I would test the service, for example, here, I mean, I always have, or the repository, sorry, I always get records. And I can construct records and compare that with the records that I get back from Hibernate, from jOOQ, sorry. But I usually do tests like this on the highest possible level. In that case, the HTTP API with an integration test. Yeah. Because I usually also use test containers for testing. With the real database, I never use H2 anymore, because the problem, if you're on that level, you may use. So the point is, jOOQ is database agnostic. So that means jOOQ tries to emulate functionality that may not exist in a certain database, that it works anyway. But if you're using certain functions of the database, and you can do that very easily, because for the functions you also get code generated if you, for example, write your own functions, then you're very limited if you use an in-memory database, because the in-memory database has not the same set of commands or functions as, for example, Postgres or Oracle has, and that's why I usually use it with test containers and avoid H2. That you mean? Yeah, that you can do that. You don't have to execute it. You can call jOOQ DSL and say, get the SQL statement, and then you get the SQL string and could check that if you like to. But I don't usually test on that level. But there are certain cases. So one thing that's maybe a bit of a downside here is because it's not a string, it's hard to take out and execute it in a SQL Explorer or whatever tool or data grip. Or if you get the query from somewhere. So I have a customer where even the project manager can write better SQL than I can, because they are working for 30 years with SQL and they know all the tricks. And sometimes I get the SQL statement from there. But I also can execute plain SQL with jOOQ. So I can directly do that. But then I lose all the fancy type safe and changeability helpers that I have here. Yeah, that's a very good question. So the point is, or the question was, how do we do integration test in a pipeline when we modify the data, and then the next test may be relying on the data set that we just modified before. So the trick is, if we use Spring, we could use transactional on the integration test that will roll back after the test method. So that could be an idea to have that. What we do currently in my project, we have a multi-tenant project, so we have tenants per test suite. So we isolate certain tests for a special schema that we have inside the database, so each test suite has its own schema, so we don't overwrite the data. But the problem is here, it's very easy because I also create the test data with Flyway, but there are not so many data. But the biggest data model I'm working on is an ERP system. They have 2,000 database tables. And you can't populate the database with 2,000 database tables with meaningful data when you start the test. So we have kind of a dump that we put in our own test image. And there we also try to to avoid overwriting of test data for the next test. But that's for sure an issue. So that's always an issue if you do integration test. How do you deal with data that may be changed by other? Okay, no more questions? Then thanks a lot for coming. And I'll be around, so if you have other questions, just come to me. Thank you very much.